Good evening, guys. Welcome to all of you. All right. Please confirm if you can hear me properly. All right. Please confirm. Okay. So, yes, we are going to continue our discussion. This is a practice session once again on coordination chemistry. Hello, guys. Good evening once again. Okay. So, practice on coordination is going to continue. Very, very good evening to all of you. Okay, so first of all, guys, informing you that if you already haven't followed me, do follow for regular updates and links. Okay, and today also we had a 5 p.m. stereochemistry session. We have discussed the topic topicity. All right, topicity in the free session at 5 p.m. on Unacademy already discussed. Also, guys, informing you again and again, if you are not yet giving this free pre-YQ mock test, please do so. All right, it's free for all of you, and there are many subjects, all the 4 subjects that you can give the CSIR net exam on. So please also share it with your friends that there are free unit-wise pre-YQ tests available, and also start giving these mock tests if you already haven't. Also, guys, we are soon going to be starting photochemistry in the plus classes. All right, pericyclic is almost complete, and here in the inorganic chemistry, we are doing organometallic chemistry right now. Okay, and in the month of June, that is from 1st of June, we are starting a new course, concept and practice course on spectroscopy. All right, and we are starting this in the month of June. Okay, so if you are interested in joining an Academy Plus, then you can do so by selecting any of these packages as you can see, and using the code Jagriti S Live. As you know, see the slide properly. Tell me once quickly, yes or no. Yes, right. Chalo, let's continue our discussion. Question number 1 for today. The spin only magnetic moment and the ground state term the ground state term for MnF6 3 minus ion is. All right. So A option is 4.9 Bohr magneton and 4F. B is 4.9 Bohr magneton and 5D. C is 3.9 Bohr magneton and 3D. D is 4.9 Bohr magneton and 3F. Good evening, guys. Good evening. Welcome. Okay, so what is the answer according to you? Yes, for manganese 3 plus. Okay, so for manganese 3 plus over here, what are you going to have, guys? Manganese 3 plus is going to be, yes, क्या होता है guys? Manganese is 3d5 4s2. So if you are removing 3 electrons, it's going to become 3d4. So what about these 4 electrons? Are they going to be high spin or low spin in the presence of a fluoride? These are going to be all high spin, all the 4 electrons. Yes, these are going to be unpaired. And what is going to be the L value? Plus 2, plus 1, 0, minus 1, minus 2, like this. Okay. So the L value is coming out to be, yes, plus 2 only. Okay. So that gives you L is equals to 0, gives you the S term. 1 gives you the P term, 2 gives you the D term, 3 gives you the F term. Alright, so this is going to give you the D term, and the 2s plus 1 value is equals to n plus 1, which is number of unpaired electrons. How many? 4. So 4 plus 1 is 5. You get the 5D term as the ground term, okay? And you are having 4 unpaired electrons, because of which, by using this formula, alright, mu effective, mu spin only formula, you are going to use n into n plus 2 whole under root, and this is going to give you 4.9 value by 4 into 4 plus 2 is 6 under root of 24. Okay, you're going to get 4.9. All right, simple question. Let's do second one. Three bands in the electronic spectrum, 3 bands in the electronic spectrum of chromium hexaamine 3 plus are due to the following transition. Are due to the following transition. Number A is 4A2G to 4T1G, 4A2G to 4T2G. C is 4A2G to 2EG. Alright, so these are the 3 transitions. What is the correct statement about them? Correct statement about them. Yes, Vishnu, all these 3 transitions are there. Okay, so A is intensity of A transition is lowest. Yes, intensity of C is the lowest. Intensity of A, B and C are similar, and the intensity of B and C are similar. So out of A, B, C and D, which one is correct? Yes. Okay, all right. So let's say we are talking about which transition is allowed and forbidden transition, isn't it? So intensity of the allowed transitions. The allowed transitions, they are going to have the highest intensity, isn't it? The allowed transitions will have the highest intensity. The transitions which are not allowed, disallowed transitions, are going to have the lowest intensity. Yes, all right. So, all right, what would you say about it? You will say that allowed transitions are those. See, this one is all of these transitions are DD forbidden. मतलब कि all of these are DD transitions. तो क्या है? Laport forbidden. They are all Laport forbidden. Okay, they are all DD transitions, Laport forbidden. लेकिन these two are at least spin allowed. Yes or no? A and B are spin allowed. Yes, right? A and B transitions are spin allowed. Okay, but however C is spin forbidden as well. It is spin forbidden as well because the delta S value is not equal to 0 over here. Yes, right? Okay, so that's the reason answer is going to be option number B. Intensity of C is the lowest. Okay, let's move onwards. The light pink color, the light pink color of CO H2O whole 6 2 positive and the deep blue color of COCl4 2 minus are due to MLCT transition, MLCT transition in first and the DD transition in the second. LMCT transition, LMCT transition in both, DD transition in both, DD transition in both, DD transition in first and MLCT transition in second. Yes, is it okay now? Yes, all right, guys. Chalo, let's continue. Yes, let's continue. So we were talking about the question number 3. What is the correct answer over here? Light pink color of this complex. This is going to be because of the DD transition, which is Laporte forbidden. Okay. So cobalt 2 plus high spin. Cobalt 2 plus high spin. How is it going to be? It is going to be D7 high spin. Alright, so it is at least spin allowed system. Laporte forbidden, spin allowed, DD transition. However, deep blue color of over here is because of the sp mixing. What happens is, guys, in the tetrahedral system there is sp mixing, and you are having the Laporte rule relaxed over here. So Laporte rule is relaxed and you have DD transition allowed. So this is your correct answer. Okay, let's move onward, guys. Question number 4 quickly. The transition 4A to G. All right, the transition 4A to G to 2EG. All right, this transition in the electron spectrum of chromium hexaamine 3 plus occurs at yes, Monica, sorry, it is going to be PD mixing. मेरे दिमाग में molecular orbital theory चल रही है, so I just said SP mixing. It's going to be PD mixing. Sorry. Yes, yes. Okay. All right, guys. So what is this transition? See, you have to, this is a mug up type question. Yes. Okay. So this transition that you are seeing is for the phosphorescence, isn't it? Chromium 3 plus. You have to remember this. It's 650 nanometer. All right, there's one more question very similar to this one. ये तो आपको याद ही रखना पड़ेगा. Forbidden transition है from one spin state to another spin state, right? Yes, it is phosphorescence. This is your excited state and this is your lower state, right? Ground state. So it is going to be phosphorescence. A very similar question to this one is this: your complex chromium bipyridyl whole 3 2 positive shows red phosphorescence due to, all right, red phosphorescence due to which transition? Due to which transition? Four A2G to 4T2G or 4A2G to 4T1G, 2EG to 4A2G, or 4A2G to 2EG. What is the logic, Shushmita? We have discussed the logic of this previous question and this one in the plus classes. We had studied phosphorescence towards the end of the plus classes, right? We had studied the TS diagrams, and after that we had discussed the phosphorescence in the last class. Okay, so you can check out. We had discussed the Tanabe-Sugano diagram of the D3 system, that is your chromium 3 plus system, right? Okay, here it's going to be chromium 3 plus, right? So chromium 3 plus is your D3 system. We have also discussed the TS diagram for it. You'll be able to see all the types of transitions, and in those transition, which one is inter-system crossing, which is giving you the red phosphorus. We have discussed all of that. Okay. Okay, all right. So which transition? In the previous one only we have done, right? Previously we have done this. You're going to get 650 nanometer. All right, this is your transition. The same thing, 4A2G say 2EG. So 4A2G say 2EG. This is what you're getting, shows red phosphorus. All right, so one more question comes on the same concept, that ruby is your gemstone, and ruby has chromium as impurity in it. Okay, so ruby is a aluminosilicate. Some of the chromium is going to replace some of the aluminium in the aluminosilicate, and that is going to give you the red color of ruby. So the red color of ruby is because of the red phosphorescence. This is your transition. This is your transition which is involved. It will approximately, not exactly 650, but yes, approximately be on this uh, wavelength. Yes, all of these things are related. Just keep that in mind. Okay, you might get a question on this. Okay, let's do an easy question now. The number of microstates for 3F term is, number of microstates for the 3F term is 3, 21, 9, 28. Yes, all right. Done. Very easy. Number of microstate for 3F term. How are you going to find it out, guys? 2s plus 1 multiplied by 2l plus 1. Yes. So the 2s plus 1 is equals to 3, because this is your 2s plus 1 term only. L value is equals to 3 for the F term. Okay. So put into this formula, 3 into 2 into 3 is 6 plus 1, 7. 3 into 7 is going to give you 21. B is your correct answer. So when you are finding it from the ground state term, all right, or let's say any term, you are going to do by this formula. Okay, 2s plus 1 into 2l plus 1 in this way. All right, let's do question number 7. See, this is a nice question. You have to choose the correct statement. Okay, based on the TS diagram, Tanabe-Sugano diagrams. Okay, so E by B is plotted E by B is plotted against del O by B the zero energy is taken as that of the lowest term. The zero energy is taken as that of the lowest term. Terms of same symmetry cross each other. Option D is two terms of same symmetry bend apart from each other on increasing ligand field strength. ठीक है, what is LFS? Ligand field strength. All right. So which of these four is correct? Correct set of statements. Option number A will be A and B are correct. Option number B is A and C are correct. Option number C is A, B and D are correct. Option number D is all are correct. A, B, C and D all are correct. Based on the TS diagrams. Yes, TS means Tanabe-Sugano diagram. Yes, Monica, it's correct only. The transition is 4A2G to 2EG. 4A2G is a higher energy term and 2EG is your lower energy term. This is for NEET, no Veginath. No, this is actually for the CSIR-NET exam preparation. CSIR-NET and GATE, not for NEET. Yes, Monica, forbidden transition है, right? तभी तो it's, phosphorescence. From the Jablonski diagram, you remember what was phosphorescence, right? It was from a triplet first excited state to a singlet S0, right? It was like this. Just a second, guys. In the previous one, you see in the Jablonski diagram, you have seen this is your S0, this is your S1, all right. This is your excitation, this is intersystem crossing triplet state, and this is going to be your phosphorescence. Okay, so from a higher excited state, that is from 4A2G to a lower excited state, that is 2EG. Okay, this is your transition which gives you the phosphorescence, luminescence. Okay. Yes, guys, what do you think is the correct answer? How are your TS diagrams represented, guys? If you have studied your TS diagram, they are going to start from 0 over here. We are plotting energy upon B, del O upon B, where B is your Raka parameter, 0, 10, 20, 30, 40, and so on. Here it could be 10, 20, 30, or here could also be 1, 2, 3, 4. All right, depending on the scale where you are getting the value, let's say it's 10, 20, 30, 40, because sometimes you get the inter-system crossing on 26, 28, 29 like that. Okay, yes, so this point is correct. ऐसे ही plot हो रहा है. Okay, zero energy is taken as that of the lowest term. Yes, absolutely. So let's say we are talking about the D1 system. Okay, D1 system TS is not asked, but this is the easiest to discuss. D1 system, you are going to split this D term, right? D, इसका orgal diagram कैसा होता है guys? For the D1 system, the orgal diagram is going to split, yes, into, alright, this is going to be 2D because only one electron is there, so this is 2D. So 2T2G, 2, 2EG. Yes, this is your orgal diagram. There is only one transition. The same thing is going to happen. The same thing is going to happen in the TS diagram. We take this horizontal line, ये जो x axis है, we take the x axis to be your 2T2G term. Okay, so whatever is your ground term in the orgal diagram, that becomes the ground term in the TS diagram also, just that it is represented into the horizontal line. So this is also correct. Okay, lowest term, zero energy taken. Terms of same symmetry cross each other. This is going to violate the non-crossing rule. This never happens in the orgal diagram or in the TS diagram. कि जो same symmetry terms है, they are never going to cross each other. Let's say example, if you see, you are splitting the F term in the orgal diagram. This is your F term, this is your P term. Okay, so for let's say D2 and D7 octahedral configuration, orgal diagram में क्या होता है guys? There is for the D2 configuration, let's say, yes, for the D2 configuration, what do you have? Plus 2 plus 1, this is going to be 3. You have the 3F term. Okay? So 3F term is going to split into 3T1G, 3T2G, 3A2G. Yes or no? And this is your 3T1G from the P term. This is 3T1G from the F. Similarly, if you have D3 and D8 octahedral, A2G comes below, and this is your T2G now. So this will be your T1G, which is coming from the F, और ये जो P है, which is only, but this is coming from the P. So these two have become the same terms. Yes or no? They are the same symmetry, T1, same symmetry terms. So same symmetry terms will try to bend away from each other. Okay, they are going to bend away like this. This is because of the non-crossing rule. So the same will happen in the TS diagram also. Okay, they are going to bend away. Two terms of same symmetry bend apart from each other on increasing the ligand field strength. This is correct, A, B and D. Alright, this is your correct answer. Guys, we have discussed the TS diagram in the plus classes. Plus students को भी याद रखना पड़ेगा. You don't have to forget these things. Non-crossing rule applies both for orgal as well as for TS diagram. This is wrong. Chalo, moving onwards. Yes, we are going to discuss question number 8. Your permanganate MnO4 minus is deep purple in color, whereas perrenate ReO4 minus is colorless. Okay, this is due to greater energy required for This is due to greater energy required for option A, DD transition in the rhenium compound compared to manganese compound. Okay, so this is because of the great energy required for DD transition of rhenium compound compared to manganese compound. DD transition in the manganese compound compared to rhenium compound. CT transition, charge transfer transition from oxygen to rhenium compared to oxygen to manganese. So this sentence means that due to greater energy required for charge transition and so on. Okay, read it in continuation. Charge transfer from oxygen to manganese compared to oxygen to rhenium. Yes, absolutely, guys. So due to greater energy required for the rhenium complex, so oxygen to rhenium compound is going to have high ligand to metal charge transfer, right? What is the charge transfer taking place? Ligand to metal charge transfer, because the metal is there in a very high oxidation state, +7, right? And the ligand is O2 minus, so it can give the electron density to the electron deficient metal, but oxygen is giving the electron density from 2p. All right, here also oxygen is giving from 2p. Manganese is accepting in the 3d, however rhenium is going to accept in 5d. Yes, 5d over here. Manganese, technetium, rhenium is there in the 5d series. Okay, so देखो 3d and 5d, huge difference. The charge transfer is not that good, so high energy is required, greater energy required. Okay, हाँ ये UV में चला जाएगा, right? So it is going to be colorless. Yes, this is going to become colorless. All right, so your answer is option number C. Let's move onwards to question number 9. We have to write question number 9 over here. NiL6, where nickel is 2 plus, there could be N plus or N minus, shows absorption bands at 8500, 15400, 26,000 centimeter inverse, whereas Ni, this is 2 plus once again, L6 dash. Okay, L dash 6, this is a different ligand. There could be N plus or N minus. This is going to show the absorption bands at 10750, 17,500, 28,000 centimeter inverse. So what are L and L dash respectively? What are these ligands? See, when I say shows absorption bands at, what are you talking about? Yes. So when I'm saying absorption bands, which means you're talking about the del O value, at least even if not the del O, you are talking about the delta value. That is your absorption maxima. Yes, that is your absorption maxima. So if the absorption maxima increases, that is your crystal field splitting increases, which means here you are having a weak field ligand, here you are having a strong field ligand. So all of these three values, if you compare in the L dash splitting is greater than L. Yes or no? L dash splitting is going to be greater than L. So you are going to have water and ammonia. Water is L, ammonia is L dash. So ammonia is a stronger ligand as compared to water. This is a very simple question based on the spectrochemical series. Okay. All right, guys. So we have done plenty of questions today. More questions are coming up. Once again, informing you all that there will be a new course launched from 1st of June on spectroscopy, organic and inorganic spectroscopy. We are going to study, right? And if you have not joined Iconic or Plus yet, you can do so by using the code Jagriti S Live. Okay, more sessions are coming up in the month of June. We are going to start free Battle of Polls as always. Yes, and be prepared for that, guys. All the topics, important topics, Battle of Polls starts very, very soon. All right. So, yes, I'll see you very soon, guys. Bye, everyone. Take care, all of you. And also, if you are liking the content, please like and share.